What's up guys, it's me Sir Ernest, and today we're going to discuss example 2.2 of Thornton and Marion 5th edition. The problem reads, if the coefficient of static friction between the block and the plane in the previous example, in this case example 2.1, is mu s, and let's say that's equal to 0.4, at what angle theta will the block start to slide or sliding if it is initially at rest? So again, let's draw our block. So this is your inclined plane with angle theta. And then let's say this is your block. If, for example, we introduce now the friction, so that means instead of the usual normal force, gravitational force, we now have an introduction of your frictional force. So because the problem says that the object is still at rest, okay, so that means we're looking for the maximum static friction. The maximum static friction is actually the Fx max. So simply F max is the maximum value of the frictional force F before the block starts to move. And this is equal to negative mu s Fn I hat. Okay, given that the x would be along the incline, and then y would be perpendicular to the incline. Okay, so similarly, if x will be along the incline, that means the acceleration will be along the incline as well. So that means we have x double dot I hat. Okay, so similarly, we can actually get the y and x components of your gravitational force, which we already found or determined in example 2.1. Okay, so now applying Newton's laws, the net force will now be equal to the sum of the normal force, the gravitational force, and the maximum static friction before the block starts to move, and is equal to mass times acceleration. Okay, so using the component method or in unit vector notation, this becomes Fn I hat plus mg sine theta I hat minus mg cosine theta j hat minus mu s Fn I hat equals mx double dot I hat. Okay, so here we can separate the components as follows. So for x, we now have m g sine theta minus mu s Fn equals mx double dot, and for y now have negative mg cosine theta plus Fn equals 0. So from the y component, we can get the normal force, which is equal to mg cosine theta. So this is the magnitude of the normal force, Fn, which we're going to substitute here. So this means that this becomes mg sine theta minus mg mu s cosine theta. This is equal to mx double dot. Therefore, the acceleration will now be equal to g times sine theta minus mu s cosine theta. Okay, so from here, just before the block starts to move, so that means acceleration is still 0. So this means that g sine theta minus mu s cosine theta is equal to 0, which give us the expression that tangent theta will be equal to mu s. Okay, so for mu s equal to 0.4, theta from here, which is calculated as arctangent mu s, and this will give us a value of about 22 degrees. So what does it mean? It means that if the angle theta is increased further than 22 degrees, the block would now start to move. Otherwise, if theta would be below 22 degrees, okay, any angle between 0 to 22 degrees, the block would still remain in place. Okay, so that's it. That's example 2.2 of Thornton and Marion 5th edition. I hope you learned something today, and thank you for watching, and see you guys in the next video. Bye-bye.